Hello everyone, welcome to my channel. This is Abhilash B, studying second year in Mr. Venkateswara College of Engineering in the Department of Information Science and Engineering. Subject Discrete Mathematics Structures and its code BCS 405A. Today we are going to discuss about basic connectives, truth tables and logic equivalence. First, introduction to logic. Logic is the study of reasoning and argument. It provides a framework for analyzing statements and their relationships. Understanding logic is fundamental for fields like mathematics, computer science, and philosophy. What are basic connectives? Basic connectives are symbols used to combine logical statements. They help in forming complex expressions from simpler prepositions. The main connectives include conjunction, disjunction, negation, implication, and biconditional. First, conjunction, also known as AND. The conjunction connective is represented by the symbol. It converts two statements and is true only if both statements are true. For example, the statement P conjunction Q is true if P is true and Q is true. Next, distinction. The distinction connective is represented by the symbol V. It connects two statements and is true if at least one of the statement is true. For example, the statement P distinction Q is false only when P and Q are false. Negation, also known as not. Negation is represented by the symbol. It flips the truth value of a statement. True becomes false and vice versa. For example, if P is true, then negation P is false. Implication, if then. Implication is represented by symbol. The statement P implication Q is false only if P is true and Q is false. In all other cases, P implication Q is considered true. Biconditional, if and only if. The biconditional is represented by the symbol. The statement P biconditional Q is true when both statements have the same truth value. This means either both are true or both are false. Truth tables overview. Truth tables are a systematic way to show the truth tables of logic expressions. They list all possible combinations of truth values for involved prepositions. Each row in a truth table corresponds to a different scenario of truth values. Constructing truth tables. To construct a truth table, start by listing all variables involved. Next, calculate the truth values for each connective step by step. Finally, populate the table with the truth values for the entire expression. Example of a truth table. Consider the P conjunction Q. The truth table will have 4 rows representing all combinations of truth values for P and Q. The resulting column shows that P conjunction Q is true only when P and Q are true. Truth table for distinction. Now let's analyze the expression P distinction Q. The truth table will show that P distinction Q is true in 3 out of 4 scenarios. This illustrates the exclusive nature of the distinction connective. Truth table for implication. For the expression P implication Q, we need to examine the truth values carefully. The truth table reveals that it's only false when P is true and Q is false. In all other cases, the implication holds true. Logic equivalence overview. Logic equivalence occurs when two statements always have the same truth value. It is denoted by the symbol, indicating that two statements are logically equivalent. Understanding equivalence helps simply logical expressions and proofs. Identifying logic equivalence. To identify logic equivalence, compare the truth tables of the statements. If two statements yield identical truth values of all the possible scenarios, they are equivalent. Common pairs of equivalence include P conjunction Q and Q conjunction P. Example of logical equivalence. The law of identity states that any proposition P is equivalent to itself. The law of non-contradiction asserts that a proposition cannot be both true and false simultaneously. Negation of P, conjunction, negation of P. De Morgan's law provides equivalences between conjunctions and disjunctions through negation. Applications of logic. Logic is widely used in computer science for programming and algorithm design. It is essential in creating valid arguments in philosophy and law. Logic always plays a significant role in mathematics, particularly in proofs and theorems. At last, conclusion. Mastering basic connectives, truth tables, and logic equivalence is crucial for logical reasoning. These concepts form the backbone of formal logic and critical thinking. By understanding these principles, one can analyze and construct sound argument effectively. Feel free to modify the content or structure better suited for it. By this, I am going to ending my video. Hope you guys like my video. Please like, share and subscribe to my channel.